Once the photon count becomes massive, stimulated emission dominates spontaneous decay. The system passes the oscillation threshold, escaping equilibrium entirely. Coherent laser light is born. If we push this technology across the electromagnetic spectrum and isolate the frequency variable in Einstein's second relation, we find a frequency cubed dependency. The consequence is severe. As the output frequency increases, the probability of spontaneous decay increases exponentially by the power of 3. This frequency cubed barrier dictates exactly why the optical laser, producing visible light, was not the first quantum amplifier built. The spontaneous losses at visible frequencies were simply too high for early pumping technology to overcome. Instead, the first breakthrough came in 1953 when Charles Townes and James Gordon invented the MASER, microwave amplification by stimulated emission of radiation. Microwave frequencies sit very low on the electromagnetic spectrum. Because the frequency is small, cubing it produces a tiny number. The spontaneous decay rate is almost negligible. The MASER was achievable first because maintaining a population inversion at low frequencies requires relatively minimal pump power. The system doesn't have to fight a massive wave of spontaneous emission depleting the upper state. If we shift our focus to the far end of the electromagnetic spectrum, we encounter gamma rays. These are not generated by shifting electrons, but by transitions between highly energetic isomeric states inside atomic nuclei. At gamma ray frequencies, the frequency cubed effect is catastrophic. The spontaneous emission rate is unimaginably fast. Because the upper nuclear state decays almost instantaneously, the population inversion bleeds out before a stimulated emission chain reaction can even begin to propagate through the cavity. To overcome this extreme rate of loss, the required pump power to achieve a gamma ray threshold borders on the limits of physics. Theoretical models suggest requiring energy events on the scale of detonating a positronium annihilation just to pump the active medium. Despite decades of research, no stable physical material has survived the energy required to laze at gamma frequencies. The medium vaporizes before it can amplify. The laser stands as a triumph of engineering against the natural tendency of matter to absorb light. By artificially enforcing a population inversion, we break thermal equilibrium. Yet, as we move to higher energies, we remain permanently caged by the immutable thermodynamic ratios Albert Einstein codified over a century ago.